Hello, everyone. Welcome to the webinar today. My name is Patrick Hill. I'm one of the founders here at Triple Point. I've worked with lagoons. I think this is my 18th year. Presented at dozens of conferences, both on the state level and at WEFTEC, and worked with literally hundreds of different lagoon owners and lagoon systems. So today I'm going to talk about testing to diagnose lagoon problems. This is kind of a two-part here. Today I'm going to talk about what testing to do, where, when, how, what's important to know. Tomorrow, Dan Johnson, our lead process engineer, is going to talk about more specifically how to analyze that data and how to understand it and how to diagnose things. So this is part of our Lagoon Masterclass series. We've been building this series over the course of, I think, 3-4 years now, defining all the key aspects of lagoons and then systematically going through. And so this is the last step. This is my last webinar I'll give in the Masterclass, which is awesome, on data analysis and troubleshooting in the last section. So we're super excited. We're hoping that, we'll have all these up on our Lagoon University site, and you can go through them one by one, and you can literally start from kind of like a lagoon novice, and work your way all the way through to being a lagoon master here if you watched all these. And so, yeah, it's a really cool resource, and I encourage you to check out our Lagoon University site, which is available via our website in the resources section. I'd like to introduce, and this will be coming out soon, so something to watch for would be our new Lagoonatic AI chatbot. I've worked really hard on this, and what we did was we combined all of the years of knowledge and information that we had, internal resources, and there's books in this, in the knowledge of this bot. There's papers, there's EPA manuals, there's all sorts of different resources that this bot draws from, and will allow you to answer, get questions answered quickly to lagoon problems that you may be having, and it'll also cite the sources that it's citing from. So it's not going to be making stuff up. We've done a decent amount of testing on this. We feel pretty good about the answers that it gives. There's might be an off answer here or there that might not necessarily be perfect, but vast majority of our testing showed this was a great resource and a great way to get quick questions answered. So this will be launching on our main site. You'll see this in the new year come through via email. I really encourage you to check it out because it's such an awesome opportunity to get quick answers to questions and be a resource. As you know, here at Triple Point, we're all about being a resource for lagoons. We want lagoons to do it better, whether they have our technology in there or they don't have our technology in it. We're here to promote lagoons within the wastewater world and see them improve over time. So today, this is the brief agenda. We're going to talk about testing to diagnose lagoon problems, starting out with why you should test, the different key variables that affect lagoon performance, the 11 things you must know about your lagoon in order to make sure it's performing correctly and continues to perform correctly, what to test for, how, when, and where to test. What are the non-empirical things, the non-testing related things that you can look at your lagoon to see how it's doing, and then keeping a record keeping and a diary so that you can track it over time and you can actually analyze this data. So why it matters? So let me give you a little story and a little background. The city of Kennett in Missouri is actually our largest nitrox installation to this day. It's a 2 MGD facility, one of the larger lagoons that we've worked on in the country. City of Kennett is the home of Sheryl Crow, for those of you that are interested in that. Basically they, like a lot of lagoons in Missouri, were having to meet an ammonia requirement. And also, like a lot of lagoons in Missouri, they did not take influence sampling. And because they're not required to. You're just required to take effluent sampling, report that to DNR. You're not required to take effluent sampling. And so, we get into this project. We're working with our engineering partners on this in terms of developing a design. Because we don't have a really good picture of influent requirements, influent, what's actually coming into the plant, we have to make some assumptions, right, about what's coming in. And, at one point there, during this upgrade process, we started up the system. This was the first winter. Sitting in my office, it's 5:30 p.m. and I'm like scratching my head, like literally the system is not doing what it was designed to do, right? The city had spent $10 million on a project specifically to treat ammonia so that they could make the DNR requirements, and it wasn't working. So my mind is racing. I go home, I'm sitting at the dinner table, I'm useless to my family. I am up at night thinking about what's going wrong. What if we can't fix this? Is my whole business going to go out of business because our technology doesn't work? What I've been doing the last 20 years, and just completely losing it over why this wasn't working. And the next morning, I get into the office. Our lead process engineer, Shakti, I see an email from him, so I open it up. And he's been looking at the data. And what he started to notice was, because we started doing this project and we started taking influent data, what he saw was ammonia was going up and alkalinity was going down. Now, I'm not going to get into a lot of detail why this is like super important, other than, I recommend you go back and look at our nitrification webinar that we did in the series. But basically, the bugs that convert ammonia into nitrate eat alkalinity. So if you have higher ammonia, therefore higher demand, more food or more things you need the bugs to convert to nitrate, and you have lower alkalinity, this is not going to work. This is completely opposite of what you would expect. You wouldn't expect at all alkalinity to change in the winter months, and you wouldn't expect your ammonia influent to change in the winter months either. It doesn't make any sense. What, are people peeing more in the winter than they do in the summertime? No, of course not. Right? And to this day, we still do not understand why their ammonia goes up in the wintertime and why their alkalinity goes down in the wintertime. The city does not have a good understanding of this at all, but this is just a phenomenon at this plant that I have not seen repeated anywhere else, really. And so he figured it out. I'm like looking at his email, I'm like, he's right. Like, there's no way this can work. We don't have enough alkalinity to treat this high level of ammonia. And I don't really know why this is happening, but we've got to show the city that, hey, if we put the alkalinity in the system will work. And so we got to work giving them a temporary system to feed alkalinity, which was a complete pain in the butt because temporary systems tend to break a lot. There's like the alkalinity fees froze or didn't mix well enough, and there was all sorts of problems. But once we got it figured out, we got it dialed in, it worked perfectly. And then the city had to go and purchase an alkalinity feed system, right, in order to a more permanent alkalinity feed system to make the system work, right? And so it was frustrating for them because, of course, the expectation was, hey, we spend this $10 million, this works. But in reality, they were going to need it anyway, regardless. Like if we'd had good data, they were going to need it. But it would have greatly, greatly reduced the fire drill if we'd had known, if the city had been taking influent samples all the way along, right, for years, we would have had a really good understanding of what was coming into the plant and what we needed to design around in order to make the system work from day one. And so, all turned out to be good. Everything works, and the city's very happy with the system. But this just shows you why it's so important that you take additional samples and you analyze these samples over time, so you really understand what's going on in your plant. Steve Harris, was kind of my mentor, and he's passed now, but very foreknown lagoon expert in the industry. And he used to talk about, lagoonies is what he called it. Like, your lagoon's talking to you, but are you listening, right? And it could be talking to you in terms of the data that it's putting out, right? And testing is not just about collecting numbers and submitting them on your DNR, right? It's about understanding what's going on across the entire plant. And that's one of the ways your lagoon's talking to you. The other way your lagoon talks to you is in what it looks like. What does it smell like? These kinds of observations are really, really important, and they tell you something about what's going on within this, essentially, a microbiological reactor that is your lagoon system itself. And so you do need to be listening. And if you listen, right, you can make friends with your lagoons. You make friends with your lagoon, it'll treat you well and treat you well over the long run. Okay, variables affecting lagoon performance. I've identified 4 main variables, and this leads us into the 11 key questions. One is lagoon design, lagoon loading versus this design, lagoon hydraulics, dissolved oxygen and mixing, and biomass. So what do these mean? So question number 1, what is your lagoon designed to treat? Really important question. When we sit down as engineers, we make assumptions a lot of the time, unless we've got better data from the influent as to what's going to be required. And we draw these assumptions from sort of industry standard. The industry standard, for example, is for the 10-state standards is that you will expect to see about 100 gallons per person per day coming into the plant. And in those 100 gallons, you're going to have about 1.75 pounds of BOD, or 0.175, sorry, 0.2 pounds of TSS, and 0.036 pounds of TK. So this example you can see here on the right, 100-person town, 10,000 gallons per day, loading of 17 pounds of BOD, 20 pounds of TSS, and 3.6 pounds of TKN. So we make these assumptions in every plant. And we call this the basis of design. Every plant has a basis of design. Every single one of them. You may not know where it is, or it's located. It's typically within the plans and specifications, or it's in documents provided to you by your engineer before the plans and specifications. It might even be in your permit. It's somewhere, and you need to understand what this is. Critical. Second piece is, what is your current loading? Right. So it's like, what are we designed to do? What are we actually doing? What are we actually seeing at this plant? Super important, right? I have dealt with at least 2 or 3 municipalities in my 18 years where they were literally operating at or above their design loading conditions. And as you can imagine, like any piece of equipment, if you try to overload it, it doesn't tend to work too well. Right? There is a design criteria that it has. Now, lagoons are very resilient, and you can abuse them quite a bit, and they will still kind of putter along. But at some point, you have to look at upgrading your facility. So 2 really critical pieces of information that you need to know relative to design loading. Now, lagoon hydraulics. 3 critical questions here. What is your designed hydraulic retention time? So what do I mean by hydraulic retention time? What I mean is, how long does the water sit in your lagoon before it flows out? Between the day it comes in and the day it goes out. That's it. And typically with a lagoon, it's about 20 days for an aerated lagoon, or it could be higher. If you have a facultative lagoon, it could be 100 days. It could be 120 days if you're in a really cold climate, right? Really important to know that. The second piece of this is, what is your current hydraulic retention time? So we all know, like, a blank sheet of paper, new hole in the ground, that is our lagoon. This is how much water it holds. This is how much flow it's seeing. This is how long the water sits there. Easy math. What is your current level of sludge in the lagoon so that you can discount that from your total volume of lagoon in order to find your current hydraulic retention time? So again, been to hundreds of lagoon sites. Lagoon sludge it's right up there, man. It's like probably one of the top issues, probably one of the leading causes of lagoon problems is that the lagoon was built 30 years ago. It has sludge buildup on the bottom, which is the design of the lagoon, is to store biosolids at the bottom, by the way, and it's never been removed. So if you had, in some cases, I've seen lagoons that are 50% full of sludge. So think about that. You had 60 days of retention on day one, and now you have 30. What do you think that's going to do to your treatment? You've just cut the time in half. It's not going to work well. And so it's really, really important that you understand the sludge levels in your lagoon and how they're building and changing over time. Again, have a whole entire webinar on lagoon biosolids. I think I have two, actually. I think I have one on the effects of biosolids and one on how to measure them. Really important to understand where your biosolids are so you understand what your current hydraulic retention time is. The next point here that I'll just touch on is where are your influent effluent structures. And the reason I say this, and Dan's going to cover this a little bit more tomorrow, is that you can get what's called short circuiting. So that's where the lagoon, water coming into the lagoon, literally takes a shortcut from the influent point to the effluent point. And when it takes a shortcut, it means it doesn't sit in there as long. And when it doesn't sit in there as long, it doesn't get treated as much. Pretty simple concept. And so if you understand where these locations are, you can understand possibly whether short circuiting is occurring, and you can also test for it as well. So really important to understand where those influent effluent structures are to each lagoon. Next is DO and mixing. So even if you're not an aerated lagoon, dissolved oxygen is really important to the process. Most non-aerated lagoons are 5 feet deep, and they're 5 feet deep for a reason. It's because they want to have surface water, air-water contact at the surface so they can get dissolved oxygen and they can have a nice, robust aerobic zone within the lagoon in order to aerobically break down waste. Now, if you're an aerated lagoon, of course, it makes sense that you have oxygen in the lagoon because you're primarily an aerobic process. You're primarily treating with oxygen. And what I could say is a very, very common thing that I've seen, right? That and sludge is broken aerators sitting on the banks of a lagoon. And they're just, or even if you have a diffuse system, broken diffusers or geysers coming up from the header that's broken underneath the water. All these things obviously have an impact on your dissolved oxygen and subsequently your mixing. So what I usually recommend is while you're doing your sludge survey, you're doing a DO survey as well. Well, a DO temperature and pH survey as well. So this is a lagoon system here in Colorado, our home state, about 3 hours away from our office. We did this survey for dissolved oxygen and set up this grid. Each one of these points on A, B, and C rows were different points where we did measurements, and we went down 2 feet, 4 feet, 6 feet, etc., until we got to a point where we were hitting the sludge blanket in this particular lagoon and took DO readings across the board. So we could understand, is this well mixed? Is the DO changing? Is there a big amount of variability between depth and location for DO readings? And then what the actual average dissolved oxygen is within the lagoon itself. So really important thing to know, and this can change throughout the year. Biomass. So 3 things on this. So your lagoon is a biological reactor, which is cool to think about. Everybody thinks, you know, reactor sounds really complex. Sounds like you got to move a lot of moving pieces. Not in a lagoon, you know. And what impacts this are your pH levels, number 1. So if you are too alkaline or too acidic, both the type of bugs that'll grow, and then the rate at which those bugs will consume the contaminants in the water are going to be impacted. Temperature-wise, you're going to digest more in the summertime than you are in the wintertime. So how cold is your water can be very predictive. And then finally as well, understanding if you have any sources of contamination coming into your system. So I typically recommend that you do a survey for pH and temperature. If you can take temperatures all year round by just looking at the water temperature transfer structures. That's actually really easy as well. But pH is a really important metric for biomass health. And then on the last one, contamination. Do you have anything that's coming in killing your biomass? So let me give you an example. Had a city put in a nitrox system. They have only one industry in town. That industry, they make seasonings, and so they make all sorts of seasonings. The good news about them was they didn't really constitute a very high BOD demand. Like, they didn't put a lot of BOD into the system. However, what we did find out is that they were cleaning their tanks and they were cleaning their all their equipment at one point a month. And in the process of cleaning that equipment, they were using a chemical disinfectant that had what's called quatamines in it, which is literally a disinfectant in the sense that it kills bugs, and specifically it impacts nitrifiers, right? The specific thing, again, they did the upgrade in order to solve, right? Nitrifiers are more finicky than other bugs, so they tend to be the ones that have the problem first if there's a problem. And yeah, it was killing their bugs, and they weren't able to nitrify, and they were busting their permit. They're coming to us and being like, hey, why doesn't our system work? And we found out that they had these quatamines coming from this industrial process. And so this could happen, out west here. It's pretty common for you to get, potentially take water from porta potties, or to take septage from RVs, for example. All these things can have nasty chemicals in it that kill the biomass. So really important to understand, are there anything that's causing contamination coming into the system that could be affecting your biomass? So last two, and this is with algae. So if sludge is one of the Achilles heels of algae, on your left foot, on your right foot, algae is the other Achilles heel, and they're related to each other. Because sludge can cause algae to grow. It can provide fertilizer and nutrients for algae to grow over time. So first question, what are the levels of algae in my lagoon? And second question is, where is it growing? So how can you get a sense of the levels of algae in your lagoon? On the right here, I've got a picture, and I think this is like kind of the easiest first way to understand. This is pictures of TSS filters prior to going into the cooker, where they just cook off all the water that's in the sample and tell you what your total suspended solids are in your plant. At the top here is the influent, and as we go down, you get closer and closer to the effluent. And what you can see is, once they force the water through the TSS filter, which is 0.2 microns, all the solids stay on one side of that filter, all the water passes through, and then you can see what the solids are that are in that water. I mean, that's pretty obvious. So at the effluent, this is kind of what we'd expect. You've got sort of gray and black, right? Gray is basically biological sludge solids, right? Good stuff. You can volatile, you could break it down, right? The black is usually like old sludge or just different things that are probably harder to break down. Then as you move through the plant, you can see that it's like green, right? So what does that tell you? Well, that tells you got algae in your plant, right? And the level of brightness tells you, and denseness tells you how dense that algae is. Here you've got the different locations within the lagoon itself and within the system itself, showing you kind of the level of algae that is growing. So the lagoon effluent is like the darkest, right? So that means that has the densest, most algae in it. The ultimate effluent is after the reactor, after it goes through a filter. So that has the lightest, right? So that has the least amount of algae in it. Now, all of that's pretty anecdotal, right? You're just eyeballing, it's not giving you any concrete data. But I say that because I think it's really important that you see what's in your actual effluent itself. If you wanted to test for algae, there's a couple different ways of doing it. One is you could test for, you could ask the lab, take them your BOD sample and say, hey, I want a soluble BOD and I want a particulate BOD. And so what do those mean? Well, soluble is literally like, what is, after we run all that water through a TSS filter, what BOD is left? What's the dissolved BOD that's in the water, right? So i.e. not algae. Particulate BOD is, once we run it through the filter, what is that green stuff? Like how much BOD does that algae actually constitute? And typically, if you see a green TSS filter and you ask them for a particulate BOD test, most of that particulate BOD is going to be algae at the back of a plant in a lot of cases. So that gives you an indicator of how much, quantifiably, how much algae is in your wastewater at that particular point. The second way to test for it is to actually get an algae probe and test for what we call chlorophyll. And you can get these probes, they're not too expensive. Dip it in the water, it'll actually tell you a chlorophyll level. And we've been doing this a decent amount. And you'll see this, if you did this every week throughout the year, you'll see the chlorophyll levels in the wintertime be low because of course algae doesn't really like to grow when it's cold as much. And you'll see it pick up and spike in like July and August when it's hottest and when it's had a lot of chance to grow. And you'll see this precipitous rise, right, if you do it on a regular basis. And that can help you to understand how much algae is growing, if you need to go out there and manage the algae in order to avoid it. And the reason you want to look at algae is because algae, if you let it come out of the back of your plant, will be BOD, it will be TSS, and it can sequester phosphorus in it as well. So these are really important things to know. So here's a summary of the 11 must-knows. I advise you to snap a picture on your cell phone of this, and you can kind of keep this as a rubrics and guide to how to understand your system and how well it's performing and how it's behaving right now. And they're tied to the key drivers. So let's talk a little bit about sampling. So I did a whole masterclass webinar on sampling for compliance. I am going to cover some of those things today in this webinar, but I encourage you to go back because in a lot of cases, sampling is really the difference between meeting compliance and not meeting compliance. And I've literally had lagoon systems come to me and say, hey, we can't meet our permit. And I'd say, okay, you should change up your sampling a little bit. You should do it like this. This is what your permit says you're allowed to do. And oftentimes you get a different result based on the way you're sampling data. And I'll explain that here in a minute. So we're going to talk about how to sample, where to sample, and when to sample. I would start by saying you really need to understand your permit and you really need to read your permit when it comes to sampling. I am by no means advocating a gaming of the system when it comes to your permit, but your permit is written in a way that gives you a guideline of how to do this. If we really wanted to get, for example, an accurate 30-day average, we would have to take a sample, a 24-hour composite sample every day of the month for 30 days. Now, I've never heard of a DNR requiring that for a lagoon system, or I don't know, for any system, to be honest with you, but maybe it does exist for larger systems. And it's not practical, and it's not feasible in a lot of these cases. But on the flip side of that, taking one grab sample a month using that as your 30-day average is not an average of anything. It's not an average. That's just one sample on the day that you took it. So I really look at it and verify with your regulator when you can sample, how you sample, that's usually the most straightforward one that you can't really mess with, other than obviously doing intrapond sampling, which you don't submit to the DNR, and then the frequency at which you sample. These are really important things to know so that you can try to be in compliance most of the time. So there's two different types of samples. There's a grab sample and a composite sample. So a grab sample is literally just, we've all done this. This is probably the most common type of sample there is. You stick the sample stick in the water, you pull it out, It's a snapshot of what's going, what you're sampling at the specific time in which you're sampling. That's it. Just like a blood test, you pull the blood now, this is what's in your system right now. Doesn't mean this is what your system was in your system this morning. Doesn't mean this is what will be in your system at midnight tonight. It's just what it is right now. And so there's sort of like very much limitations on this type of sample. It's cheap, it's easy. That's why it's common. That's why it's typically the one that DNRs will allow you to do. But I don't see it as a particularly accurate sample. The other one is a composite sample. So we might have seen this before. This is you get the composite sampler. It has a hose on it. You put it in, for example, your influence structure. And what it will do is it'll pull a little bit of sample every hour for 24 straight hours to create a composite of everything that's gone through the plant, or little samples of what's come through the plant for 24 hours. So obviously a lot more accurate. It's going to be more reflective of a 24-hour period rather than just a specific moment in time that you would happen to be there and put your dipstick in the water. One of the things that I think where at a very bare minimum that's critical about sampling and the method you choose is that if you're going to do an influence sample, I highly recommend that it is a composite sample, not a grab sample. Here's why. So this is a facility, this is some real data from a facility where they were taking composite samples and grab samples, right? So they had the composite sampler set up, it's pulling a little sample for 24 hours at their influence structure. And then, John would go out there once a day, he'd pull his grab, or on the frequency they were going to do the sampling, pull his grab and run tests on both. And what you can see here is that the composite samples were 21% higher than the grabs. Why? Well, think about it. What time of day was John pulling the sample? Well, he could have been pulling it at noon. If he was pulling it at noon, he's probably going to get a lower result than if he pulled it at 8 a.m. when most of the water's coming into the plant, when everybody's getting out of bed in the morning, going to the bathroom after they get up, flushing their toilets, etc., or in the evening for that matter. So that's where grabs really fall down. And this could just as easily, I've seen this flipped. I've seen it where the grabs are 30 or 50% higher than the composites because the operator is pulling the influence sample at the beginning of the day, right? When the most waste loading is coming into the plant, right? And so if you're gonna do, what I found in my experience is with lagoons, if you're gonna take influence samples, which I highly recommend that you do on a periodic basis, composite samples is absolutely the way to go. If you're going to take effluent or intrapond samples, grabs are totally fine. We did the same analysis where we had grabs and composites at different points along the system. And after you get through the first lagoon, it pretty much equalizes, right? Such that there wasn't a whole lot of difference between the composite and the grab. You might as well just take the grab because buying the composite sampler is costs money to buy and maintain. If you cannot afford a composite sampler, that is fine. You can kind of create your own composite. So you go out there at 3 or 4 different points in one day, and you take a little bit of sample, a little bit of sample, a little bit of sample, mix them all together, right? Then take that to the lab. So that works. It's not quite as good as the 24-hour composite, but it does. It will satisfy the requirement of a composite. So, I just covered this. So where do you want to pull your samples? Most municipalities just pull an effluent sample, and I get it. It's all that's required by the DNR in a lot of cases, and that's why they do it that way. They're just trying to keep costs low. They just see the results of the process. And I'm not saying that that's not valuable. Obviously, an influence sample is really valuable. It's going to tell you whether you're in compliance or not in compliance, but it doesn't tell you why your effluent sample is what it is. It doesn't tell you where the treatment is occurring. It doesn't really provide a lot of information other than this is what's coming out right now, or If you're taking a grab sample, it's like, this is what was coming out of the pipe on the time that you put the dipstick there, right? It's not giving you a lot of information. It's not going to help you diagnose anything or trend any data or understand a whole lot about how your system is operating. So we highly, highly recommend that you take intra-pond testing. So what do I mean by that? So you take influent testing, you take after pond 1, after pond 2, after the final pond. And obviously you could have fewer cells than that, or maybe you have a baffled turn, but you get my point. Just along the process, you're taking different points along the process. And it is super important because it helps you to understand what is going on in the process. So for example, 10-state standard, most lagoons are designed that you get 80% of your BOD removal in Lagoon 1. Okay? And if you're not seeing 80% removal in Lagoon 1, it could be that you have too much sludge in Lagoon 1, your HRT is too low, for example. Could be that your influent loading is too high, for example, right? You're getting more loading into the system. Maybe you have an industry that's exceeding their waste load, agreement. Could be a lot of things, but you're not going to know that unless you do the testing to find out. Here's an example, and this is one I've used several times. We have this lagoon system, Lagoon 1 far left here, Lagoon 2 in the middle, Lagoon 3 at the end. And that Lagoon 3 is a polishing lagoon, so it's quiescent. And we took samples after Lagoon 2 at the effluent point at the back of the plant, right? And what we found was we were treating ammonia coming out of the first 2 lagoons in the summer months. But what we found was that in a lot of cases, the ammonia coming out of the back end of the last lagoon was actually higher than what was coming into that last lagoon. Which it's a head scratcher, right? Like, wait a second here, isn't the water supposed to get cleaner as it moves through the process? Well, you're correct. It is supposed to get cleaner as it moves through the process, but it actually got dirtier in the sense that the ammonia was actually higher in some cases coming out of the last pond versus what was going into it, right? Well, again, you don't take this sample, you don't know that, right? You have to take the intrapond sampling in order to understand what's going on between Lagoon 1 to Lagoon 2 to Lagoon 3. What was happening here, as it turns out, as you can see in this picture, this last lagoon was covered with duckweed. And what duckweed does is it actually assimilates ammonia into its cell wall as it grows. And then in the wintertime, when it dies, that dead duckweed sinks down to the bottom. And when the following summer comes along, that dead duckweed will break down anaerobically, re-releasing that ammonia back into the water column, causing the ammonia to be higher on the effluent than it is on the influent. Now, again, you wouldn't know that unless you did the intrapond sampling. And now you know potentially that you need to address some of the biosolids that are in that final polishing cell so this phenomenon doesn't get worse and you end up violating your ammonia permit. And this can be true of algae and that driving BOD and TSS. It can be true of a lot of things. So highly, highly recommend intrapond testing. And then the when also is very important when it comes to algae itself. So Dr. Linville Rich, one of the sort of godfathers of lagoon study, passed away, some years ago, wrote several books on lagoon treatment, really kind of an authority on this stuff. If you are interested in having a textbook on lagoons, he's got some good ones. And he said, right, the second myth is that the effluent BOD5 or CBOD5 is the residual of what's coming into the influent lagoon, when in fact, most of the effluent BOD5 coming from lagoons is due to algae growth. So think about that. It is not that the lagoon, in a lot of cases, is failing to treat the influent load coming from the collection system, the pee and the poop, or in the case of an industry, the byproduct from your process. It's not that it's failing to do that. It's doing that. It's just that algae is growing in the lagoon, which is then flowing out of the lagoon and showing up in your sampling as BOD TSS, phosphorus in some cases. So that's the issue. To back this up, in a study of 24 Colorado municipal wastewater lagoons, it was found that 2/3 of them, of their effluent violations, were due to algae growth, not due to the fact, right, that they weren't treating the influent actual BOD and TSS that was coming in. So algae plays a huge role in terms of what you're seeing on the back end of your system and what BOD and TSS you're seeing coming out of the plant. So algae, like any plant or aquatic plant in this case, thrives in sunlight, and it photosynthesizes, so it's going to be at its highest at solar noon, and it's also going to be going to live mainly in that first 2 feet of water column where the sunlight can penetrate and actually help it to photosynthesize and thrive. So what does this tell you as to when you should pull your sample? What it tells you is you shouldn't pull your sample at solar noon. This is what it tells you. Now, if you want to have a composite sampler on your effluent, right, that's fine, right? You can do a composite sampler on your effluent, and this will normalize this effect. But if you're pulling grab samples, you should be pulling that water for your grab sample from the deepest possible location at either 7 a.m. or 5 p.m. or beginning of the day or end of the day, when the sun isn't high in the sky, because otherwise you're just going to get a massive impact of algae on that data that you're going to get out of the plant, and it's not going to be super informative as to actually what's going on. Now, if you want to test your algae levels, solar noon is the time to do it, right? But it will fluctuate at different depths and at different times of the day. I think that one of the big things with the time of day reading of samples is whenever you pull your samples, just keep it the same. Keep it the same time of day. Don't vary it, because it's hard to compare one sample that was pulled in March at 5 p.m. and one sample that was pulled in March at noon. It's hard to compare the two because they're going to vary based on algae growth. And so just pick a time of day, keep doing it at the same time. Second aspect as to when is weather related. So as you can see here, this is a graph of a system with some TSS plot points on here, showing you what's coming in versus what's going out of the plant. And what's coming in is steady, 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 and then boom, big spike. So what's happening here? Well, the big spike's a rain event, right? We all see them. We've all got I&I issues. We all get a spike in flow when a rain event occurs, if you're a municipal lagoon system. And my point here is that if you get this spike in a rain event, this is not a particularly good time to pull a sample for a couple of reasons, okay? One is you're either going to get a diluted sample, right? Which you might say, oh, well, great, my milligrams per liter is going to go down, okay? Oh yeah, it will go down. However, you might struggle to meet your percentage of removal requirement if you have one, because all that rainwater comes in, it's going to dilute your sample down, and it's going to then mean that you're calculating your percentage of removal across the plant. It's going to dilute that percentage of removal. You could be putting out beautiful water, however, you're not actually treating enough water according to the DNR in order to meet that. Or what it's going to do is it's going to create this spike in loading. It's going to create, it's going to push water from the front of the plant through the plant in a way where kind of like a plug flow, before it gets diluted, it's going to push this concentration of water through at a rate that you don't have the biomass to support and treat. And because of that, you'll see this instantaneous load. That instantaneous load is going to mean that your effluent actually gets worse for a certain period of window as a result. So I generally tend to recommend that you kind of avoid pulling samples around rain events. You need to look at the weather. You need to understand when the rain event's occurring. Wait, if you can, to pull your sample outside of these rain event windows. Pull it before if you're not going to get rain in the middle of the month, or pull it after 36 to 48 hours after the rain event has passed. So what to test for? BOD. There's several different types of BOD. There's BOD5. There's soluble BOD, which is where we filter the BOD and to see what dissolves dissolved in there. There's particulate BOD, which is the what kind of oxygen demand do the particles that you filtered out constitute. Then there's carbonaceous BOD, which is basically where we eliminate nitrifier growth within the sample itself. And then soluble carbonaceous BOD, which is basically we filter it, we eliminate the nitrifier growth, and then we see what kind of soluble BOD is left in it. All of these tell you something different. Dan will talk about these a little bit more tomorrow as to what they tell you and why. We already talked about why particulate BOD could equal algae, and that may be a good indicator of algae, but they can all give you some predictive value. Obviously, you want to test for TSS. Now, TSS is all solids that are in the water, and that can be anything from algae to sludge particles to metals to all sorts of things that are suspended in the water column themselves. And so, you know, you're not going to, TSS sample is not going to tell you what specifically it is the composition of that TSS, but if you look at that sample like I showed before, you can see if it's green, then it's algae. Then you look at nitrogen. So if you have an ammonia limit, you could test for NH3, NH4. That tells you your total ammonia nitrogen. If you have a TN limit, then that's going to be testing for ammonia plus nitrite, and organic nitrogen. If you have TKN, that's testing for ammonia nitrogen and organic nitrogen. And if you have a TIN limit, like they do in Colorado here, that's testing for ammonia plus nitrite plus nitrate. These are all the different forms of nitrogen that you can test for. And then finally, phosphorus. So phosphorus, total phosphorus is a combination between orthophosphate, polyphosphates, and organic phosphate. And when it comes into the plant, most of your phosphorus is particulate form, so it's in the solids itself, it's bound up in the solids. As it moves through the plant, it gets converted into soluble phosphorus, and that's what orthophosphate measures. And then as it pulls out, if you add chemical or do some biological phosphorus removal, for example, in lagoons, this would be like algae or duckweed assimilate phosphorus into the cell wall, then it dies and sinks down to the bottom. That ends up back in the particulate form. So one reason I say this is like orthophosphate is actually a relatively easy thing. You can get ORP probes that you can test pretty easily what the phosphorus is if you don't want to send it to a lab. Otherwise, total phosphorus can be a really good indicator. So this is a summary of all the different things we recommend that you test for across the system in order to get a better understanding of where you're at. Now that you've tested for these things, the other things I think are really important is you got to use your senses. So what is going on in your lagoon? What can you see your lagoon? It's trying to talk to you. It's going to tell you based on the way it looks how it's feeling. So if you see popping sludge, that means you probably have too much sludge and you've got anaerobic digestion going on at the bottom. If you see lots of algae, that also could be an indication of sludge. What are you smelling? How does it smell? So to give you a general sense of lagoon color, we have a nice blog on this. You can check it out. Typical healthy lagoons, like a brown lagoon, you get a brown water look to it. That's very healthy. If you've got this pea soup or green streaks, that's overgrowth of algae or cyanobacteria, harmful algal blooms. If you've got duckweed growing on it, typically that's a sign that you've got a decent amount of ammonia in your system that you probably need to treat for, or you have a lot of sludge on the bottom. If you've got red or pink patches, these typically show you that usually it happens in a low dissolved oxygen environment. If it's clear, it's a lot of ammonia, can be also good, means you got clean water. If it's gray or black and it looks like black death, you got a major problem on your hands. That's anaerobic digestion going on in the lagoon. Your lagoon is dying, which you do not want. We've all heard lagoons smell. Well, that rotten egg smell that the neighbors hate, that's because you do not have enough oxygen in your system. You are breaking down solids anaerobically within the system itself. If you've got that earthy pond smell, that's the one that you want. But these things, these sights and smells indicate something. And I highly recommend that you make these observations and you take pictures and you note it in a diary along with the rest of your data set, so that you can correlate, you can start to correlate the data points that you're seeing with the sights and smells that you're observing. This is super, super important. The second part of this is you need to pull all of this information together, and I highly recommend that you have it all in one spreadsheet. So I can't tell you how many times I've seen operators, they've got all their DMRs, they submitted them all, they're all separate spreadsheets. They do not compile them together, they don't have a unified data set in one place. Obviously, you have to submit your DMR, totally get that. However, I recommend that you pull all that data into one central spreadsheet and then pull these observations from your diary into this spreadsheet, maybe link some of the pictures from your cloud. And so you can start to look at all that data from a holistic perspective and start to trend it and start to see what's happening at different locations within your pond. So here's your checklist. You should be putting a composite sampler at your influent and taking regular composite samples. You should be doing a biannual lagoon survey. So sludge survey, temperature survey, DO survey, pH survey of all your different lagoons. You should be doing intrapond testing, at least quarterly. You should be taking your influence, your after pond 1, after pond 2. You should be having a weekly diary where you're taking pictures, you're observing sights and smells of the lagoon. You should be monthly tabulating your data and putting it into a central spreadsheet. And quarterly, you should be trying to do data analysis. Some recommendations on kind of a toolbox. A handheld DO probe, you can buy these for about $1,500 to $2,000. You can get DO, pH, and temp, usually with those probes. A handheld colorimeter will help you test ammonia, ORP, I believe, nitrate, different things like that. That's about $2,000, $2,500. A laptop, a sludge judge, a Setchijix, a John boat, portable composite sampler, sampling stick, and if you want, you can get an algae probe as well that tells you the level of chlorophyll that's in the pond, so you can more adequately predict when algae is going to spike. So here's the sample, sorry, the chapter summary. I think this is really critical. What I see far too often with operators is that they don't compile the data, they just kind of send it in the DMR. I can often see, honestly, like they don't even look at the data. And that's fine until you have a problem. And if you want to have the predictive value of being able to understand what's going on in your lagoon system, you need to keep this data and you need to be able to analyze it, track it, and ultimately stay on top of what's happening within your system. So with that, we got a few minutes for questions. Sorry, I went a little bit over what I thought with my ranting and raving. If you put the questions in the chat, he will read them out to me and we can kind of go from there.
Here's the first one. Does Kennett have a large school? I've seen instances where ammonia loadings increased during the school year and we traced it to a grade school. Our theory, the school had a large population of kids that weren't normally in the town on their sanitary sewers, and for whatever reason, when kids are at school, they tend to only use the restroom in a way that sends ammonia down the line.
Yeah, could have been. I mean, obviously they have a high school, they have middle school, they have all the schools in town, so that actually could explain it. The other thought we had was, were they getting infiltration and inflow from the anhydrous and such that would run off the farm fields and seep into the ground at the end of the growing season? That was my other thought with them. So yeah, good point.
Have you looked into an analysis of the microorganisms in a lagoon sample as a way to understand the health and population of a certain microorganism?
You could definitely do it. We have done it mainly as a result of at the back end of our nitrox system to understand where the nitrifiers are growing and what species they're growing on. It's sort of it can be a really cool test to do, but it's kind of expensive to do it. And so they give you a really broad spectrum look at what populations and what are the the genuses of those populations that are growing, but it would tell you a lot. Just like a gut microbiome test will tell you a lot about what's going on in your own body.
Because sludge has such an impact on overall lagoon treatment, how often do you recommend doing a full sludge survey? And is this something you can do yourself?
At least once a year. And yes, you can absolutely do it yourself. So again, I go back and recommend watching. We have a specific webinar that deals with how to do a sludge survey. It's not that hard. It would take you, and for most lagoons, probably a day and a half, and 2 people. But at least once a year. Ideally, if you're going to get out there and do a DO profile and things like that I recommend, twice a year, because it's not that hard once you're on a boat and you set up the grid to do that as well. But yeah, once a year.
And then how often should the biosolids be removed from a lagoon?
Well, it depends on the rate of growth. Sorry, the rate of input into the lagoon itself. But the rule of thumb is always like once every 20 years is kind of like the 10-state conservative design standard. The reality is that because you're never actually loaded at the design loading that the 10-state standards makes you design around, it ends up being once every 30 years. But it depends on the site and the rate of sludge accumulation and the weather and things like that. But if you can't remember the last time it was done, or if it was never done, I'd start looking at it.
When we are doing an LC50 test on our lagoons, the fish keep dying from the ammonia toxicity. How can a northern cold climate aerated lagoon system deal with this?
Well, the issue is that the nitrifiers that will break down the ammonia that's causing the fish to die don't like to grow in cold weather. And so we did a whole webinar on nitrification, which I encourage you to watch, but you really need a specific nitrification reactor that's designed to nitrify in cold weather. So our nitrox system is one of those, but there are other systems on the market as well that can do that. You can literally bolt onto the back of your plant. And unfortunately, that's just it. Yeah, the ammonia, you need to convert the ammonia into nitrate to stop the toxicity.
If struggling with ammonia but no duckweed is present, are there other signs to look for?
I think just testing the ammonia, that's the way to do it. And like I said, you could buy the Hawk DR900 and do your own test. That's not too expensive. I think those are the big things. Ammonia will affect algae growth as well. But algae just tends to grow in lagoons anyway. So I think you just need to test your effluent ammonia.
Is there a type of probe you would recommend over others for testing, like Hawk meter or other brand?
So the DO probe, the one that's so common that I've seen is the Hawk one, but YSI also makes a DO probe that you can attach like pH, and most DO probes will do temperature as well. I wouldn't recommend any of the ammonia probes. Ammonia probes are not really designed to give you super accurate data on ammonia, especially at low levels of ammonia, which, in the grand scheme of things, most lagoon ammonia is pretty low anyway, even if it's at 30 milligrams per liter. So if you're going to do ammonia testing, you really want to use a colorimeter method. It's going to give you a way more accurate result than a probe. ORP probes are good and reliable. Nitrate probes, not great. Colorimeter is better for that. Yeah, that's what I would recommend.
That was our last question. Certificates will go out in an email in about an hour.
Excellent. Thank you very much. I really appreciate you guys joining. I hope you all can join tomorrow to Dan's presentation. I reviewed it with him yesterday, so it's going to be great.